So what we just looked at is we had before a table of our time periods and our ends, the amount of bacteria we had. We had our numbers in here. It started off 2,500, 3,250, and we just said if we worked out log of n, the values we would get over here, if I then graphed t against log of n, instead of getting a curve like that, I actually get a straight line. And if you graph log of something and you get a straight line, that means you've got exponential growth. So the key thing there is it's log of something, and that's a straight line. That is what happens if you have exponential growth. If you had exponential decay, the line would just be going down instead of going up. Okay. When this goes on the KLP, I'll put a printout of that in there as well. So what I want to do now is just another example, this time on population growth. So the next example we're going to look at is on population growth or population decay. Can we move on? What's on the board? Okay, so the next example, population. What we are having, and we'll just sort of summarise the things we've got here, is we've got the population on an island is decreasing at a rate of 5% per year, per annum, and the population at the moment, the population now is 4,328. What I want you to do first of all, or what we're going to do together, is come up with a model for it. Model, that means like the formula to model the growth. I want to know what the population will be in 5 years' time. And I also want to know how many years' time it will be when the population has halved. So how many years until the population has halved? So that's the question that we're going to look at next. Okay, Laura, I think if you start taking notes at this point, you'll be fine. Okay. So, what letter should we use for population? If we can do one, yeah, P. Okay, so we'll use P for population. That makes sense. What letter should we use for our time period? T. Okay, that makes sense. So our model, before we put any numbers in it, what will our model look like? From what we've done so far, from our previous models, what will our basic model, our basic formula look like? Bethany.
M equals...
I'm going to have my P this time, because that's what I'm modelling. Rather than, it was M last time for something, but I'm going to have P now for population.
Equals A times B by P.
Yeah, okay, that's my basic model.
Why is population to the power of n?
Sorry, that's just my abbreviation for population.
Oh.
Sorry, that wasn't a power of N. Sorry, okay, that's just my shorthand writing population. Okay. I can understand if you thought it was power of n, it would be very confusing. Sorry. So yeah, that's our basic model. Okay. Alice, can you tell me straight away what A or B are?
Is A 5%? No, B is 5%.
Okay. B is going to be related to the 5%. And we're decreasing at 5%. If you go down 5%, how much have you got left each time? If I've taken 5% of your money away, what percentage of your original money have you still got?
95.
Yeah, okay. So we were decreasing here. So B is 0.95. That's because if you're decreasing by 5%, you'd have 95% left. So you always think if you're decreasing, what have you still got? 95%. Change it into a decimal, 0.95. So that has come from the decrease of 5%. That's where that's come from. Right, can you tell me what the A is?
4328.
Yeah, that's right. A is always the initial amount. So my model, my formula, if I just substitute those numbers in, becomes P equals 4,328 times by 0.95 to the T. So that's my model. That's the key thing in this question. So, first thing I asked you to do was to work out the model. We've got that. Then I wanted to know what the population would be in 5 years' time. Leon, what do I do now then? How do I use this model to find out what the population will be in 5 years' time?
Would you put 5
In for?
time?
Yeah, for T. There you go. Just let T equal 5. That's right, okay. Just let T equal 5 and you'll find then the population in 5 years' time. So you'll just do that sum. Okay. I don't know if anybody's done it already, but I reckon that answer is 3349. So in 5 years' time, there will be 3,349 people on the island. The third thing we had to do was say how many years it will be until the population has halved. Can anybody think how we might do that? How many years it would be until the population has halved?
Give it a simultaneous equation.
We won't need a simultaneous equation. We have got to get some sort of equation.
4328 divided by 2.
Okay, that's a good start. Yeah, so let's basically first of all find out what half the population is. Okay, so Bethany's just said let's do 4328 divided by 2. That will actually tell us what half the population is. And if we do that, we get 2,164. So that's the population that we're interested in. So now I know that figure. What can I do now? I want to know what time it will be, what time period when I get that P. Yep.
Is it log? Well, not log, but that times 0.95 to the power of x. And then
We will have to use logs in a minute. But can you think of just one nice, clear mathematical statement you could write down, or something similar to this here?
0.95 to the power of x equals 2,164.
We're getting close, okay? I'm just going to write down this model again that we've got.
2,164 equals 4,328 times 0.95 to the power of T.
Yeah, that's correct, okay? What we have done now, we have let P be the population we're interested in our model, and what we've now got to do is go and find T. So yeah, that's what we do. Just like here, we let T equal something and we had to find P. Now we're letting P equal something and we've got to go and find out what T is. So I've now got to solve this equation here. What would be the first thing you would do if you were going to solve that equation? What would your first step be in solving that equation?
Dividing 2,164 by 3,300. Is then 4,000. 4,000, yeah. That's
Yeah, so the number you're going on about, dement. Yes,
Yeah.
that's right. If we divide that, then over here I get 0.95 to the power of t. And what is the answer to that division? What is that number there? What's the answer? Division of half, yeah. It's because we set it up to be. So I've actually got now 0.5 equals 0.95 to the power of t. Now, how do I go about solving an equation where the unknown is a power? And Eve, you suggested something earlier, which now does come in here.
no.
Take logs, yeah. What you need to do now is take logs of both sides. So I'm going to write this out in full, in case you've forgotten how to do it. I'm going to take log of the left-hand side, so log of 0.5, and I'm going to take log of the right hand side, so log of 0.5 to the t, and I'm going to put that in brackets to show what I've done. So I've taken logs of both sides. Right, now what?
If you take
Yeah.
t to the full log.
Yeah, that's right. A power up here can come down into this position here. That's right. That's what you can do with logs. So the left hand side stays the same, but that t can come down and multiply by my log of 0.95. So that t is being multiplied by that. Now I want to find out what t is. So what's my next step then to go and find out what t is? Go on, one of you.
Log 0.5 divided by log 0.95.
Yes, that's right. If I work that out there, which you can just type in your calculators, you will get the time period we're after, how many years' time it will be when the population of the island is halved. Has anybody got that?
13.5.
Yeah, 13.5. So in other words, in 13.5 years, the population will have halved.
Would you round up?
No, because that's fine. You can leave it like that because your time, it's a continuous measurement. 13 and a half years is a sensible answer, so that's fine.